the last lesson in our book, lesson 13.8, is a problem-solving lesson, finding misleading statistics. Essential question: how can you use the strategy work backward to draw conclusions about a data set? So Mr. Owen wants to move to a town where the daily high temperature is in the 70s most days. A real estate agent tells him that the mean daily high temperature in a certain town is 72 degrees. Other statistics about the town are given in the table. Does this location match what Mr. Owens wants? Why or why not? Use the graphic organizer to help us solve our problem. So what do we need to find? Well, the first thing we need to find is the temperature usually in the 70s? What information do I need? I need the statistics or the data in the table. You could have used either one of those words. Okay, how will I use the information? I will work backward from the statistics to draw conclusions about the distribution, how it's spread out, how it is, how far apart the numbers are of the data. All right, so our minimum high temperature is minimum high temperature is 62 degrees. The maximum high temperature is 95 degrees Fahrenheit. The median is 69 degrees Fahrenheit. All right, so the high temperature is sometimes less than 70 degrees, right? The 62 is less than 70 degrees. But sometimes the high temperature is more than 80 degrees. So the median is the middle value in the data set. Okay, because the median is 69 degrees, at least half of the days must have high temperatures less than or equal to 69 degrees. At least half of the days has to be less than or equal to 69 degrees. So 69 would be in the middle. We've got some 62s, some 61s, and so on. Or actually, nothing's lower than 62. So there would have been like 65s and some other numbers. Then we had some that were higher than 69. And so this was the number that was in the middle of our data set. So the location does not match what Mr. Owens wants. Half the days are colder than what he would like. The median indicates that most days do not have a high temperature in the 70s. So the median told us, this isn't what he wants. Because at least half the days are lower than the 70s, and he wants to live in a place where the temperature is usually in the 70s. All right, Ms. Garcia is buying a new car. She would like to visit a dealership that has a wide variety of cars for sale at many different price ranges. So yeah, there's some big price ranges here, $12,000 to $65,000. All right, the table gives statistics about one dealership in her town. Does the dealership match Ms. Garcia's requirements, and explain our reasoning? All right, so what do we need to find? Well, we need to find whether or not this dealership has a wide variety of car prices. So does the dealership have a wide variety of cars at different prices. All right, so what information do we need to find? So we need the statistics on the car prices in the table. So what information do we need? The statistics, make that part of the same word, of the car prices in the table. And how will I use this information? So we're going to try this work backward strategy again. So work backward from the given prices to see how they are distributed, to see how they are distributed over the range. Okay, so we're going to create a dot plot. These are new car prices in thousands of dollars. So this is $40,000. It's not just 40, it's 40,000. This is $65,000. This is $10,000. Okay. All right. So we have one at 12,000, which would be right about there. Yeah. So here we have one right there. Highest is 65. We have one at 50,000. We have one at 55,000. We have one at 60,000. Oh, now look at that. Once we've plotted it out, there's a huge gap here. Is there really a wide variety of car prices here? We have one kind of outlier, don't we? And then most of them are within $15,000 here. They're kind of grouped together. All right, so the range of prices, let's figure out our range. So the range is what, 65 minus 12, which is $53,000. All right. Our interquartile range is 60 to 55, 60,000 minus 50,000, which equals $10,000. So in other words, there's a difference of $10,000 in the interquartile range. All right. So even though when we first looked at this data, we thought, oh yeah, they got a wide variety of prices, all the way from 12,000 to 65,000. But the reality is, once we really looked at it, this range of prices from the lowest to the highest is not representative of what's actually in the dealership lot. Yeah, there's one down here, but it's an outlier. Most of them are right in here, and this interquartile range tells us that most of the cars on this lot are within $10,000 of each other, which is not as wide a variety as what Ms. Garcia is really looking for. It's actually a relatively narrow variety. So the dealership does not meet Ms. Garcia's requirements. They really don't have a particularly wide variety of cars there. So what would a dot plot look like for a dealership that does meet her requirements? Well, the dot plot would have X's all throughout here. Not a whole bunch down here and just one over here. There would be X's throughout. So we would say well, I should call them the dots. The dots would be scattered throughout the number line, not just clustered in the upper quartile. Or you could say there would be more dots, let's say, in the lower quartile range, because there's hardly any. Those aren't actually there. There's almost nothing down here. Most of the cars are in the upper quartile range. Okay, last page. Josh is playing a game in the carnival. If his arrow lands on a section marked 25 or higher, he gets a prize. Josh will only play if most of the players win a prize. The carnival worker says the average or the mean score, these are synonyms. Average means the same as mean. Average score is 28. The box plot shows the other statistics about the game. Should Josh play the game? And explain your reasoning. All right, so first look at the median. All right, our median is 20 points, right? Next, work backward from the statistics. The median is the middle value of the data. So at least half of the values are scores less than or equal to 20, right? This is the one in the middle. That means half the values are less than or equal to 20. It's 28, the box plot shows. Okay, finally, use the statistics to draw a conclusion. So if half of all the players earn 20 or less points, that means that most players do not win a prize, right? You have to get 25 or higher to get the prize. Whoops, I'm not on the screen. We have to get 25 or higher to get the prize. But more than half the people are getting 20 or less. And there's just a few that are getting 25 or more points. So should he play the game? No, he doesn't have a very good chance of winning. So the answer is half the players are earning 20 or less points. Therefore, Josh should not play the game because he does not have a good chance of winning. All right, what if a score of 15 or greater resulted in a prize? Would that affect Josh's decision? Absolutely. If most of the people, if at least half the people are getting at least 20 points, and all you had to get was 15 to win, his chances go up dramatically of winning. So yes, this does affect. How would that affect his decision? His chance of winning improves, so he would want to play the game because most of the people are going to be getting 15 or more points. I mean, look down here. In our lower quartile, there's very few people getting less than 15 points. So, yeah, it improves his chance of winning, and therefore he probably will win. All right, a store collects data on the sales of DVD players each week for 3 months. Okay. The manager determines the data has a range of 62 players and decides the weekly sales were very inconsistent. Use the statistics in the table to decide if the manager is correct and explain your answer. Okay, so there's 62. Okay, so our range of 72 minus 16 got us the 62. That's where the 62 came from. Weekly sales were very inconsistent. Okay, so the minimum was 16, maximum, lower quartile, upper quartile. Okay. Although the range is 62 DVD players, the interquartile range is only 14. From the lower quartile. So the answer is no. No, he's not correct. So although the range of DVD players is 62, the interquartile range is only 14 players. The range is affected by the minimum of 16. So this is essentially an outlier pulling the range. The range is affected by the minimum of 16, which is probably an outlier. So So this 16 is much different from these other numbers, and it's skewing the manager's perspective. So it is worthwhile so the sales were not inconsistent. These are all pretty close together. This is just way out there, is what we're saying. Okay, all right, good luck.